Okay, welcome to Mrs. Merkel's Trig class. We're going to start out with a prayer. In the name of the Father, and the Son, and the Holy Spirit. Amen. Ave Maria, gratia plena, Dominus tecum, benedicta tu mulieribus, et benedictus fructus ventris tui, Iesus. Sancta Maria, Mater Dei, ora pro nobis peccatoribus, nunc et in hora mortis nostrae. Amen. In nomine Patri et Filii et Spiritus Sancti. Amen. Okay, the long-awaited video for 12.2. All right, 12.2 is trigonometric functions and angles. Now, you're used to seeing triangles and using trig functions with triangles, but what we're going to do now is we're going to put our triangle in the XY axis, okay? So what we do is we're going to draw an XY coordinate system. And remember, this here is our initial side, and this is our terminating side, okay? This is X units away. This side is Y units, and they call the hypotenuse R. Also, remember that R squared is equal to X squared plus Y squared. And that comes from the Pythagorean theorem, okay? So let's go over now, and this should be review. The sine of theta is equal to the opposite over the hypotenuse, but in our case, the opposite is the Y value, so it would be Y over R, okay? The cosine of theta is equal to the adjacent over the hypotenuse, which is equal to X over R, and the tan theta is equal to the opposite over the adjacent, which is equal to Y over X, okay? What this allows us to do, what the problem may look like at this point now, is they're going to give us a point. Let's say our point is 4, 5. So we go 1, 2, 3, 4, 2, 3, 4, 5. And this is the point 4, 5 right here. Okay. And then we are going to draw out to that point. All right. And make a triangle like this. So it looks like the triangle above. Then what they're going to do is they're going to ask us what the sine, the cosine, and the theta are. So the first thing that we have to do is we have to find out what R is equal to, okay? So R squared is equal to X squared, so that would be 4 squared plus 5 squared. So R squared is equal to 16 plus 25. We take the square root of both sides, and you get R is equal to the square root of 41. All right, so now let's take a look. What is the sine of theta? Now this is our theta here, all right? So the sine of theta is equal to opposite over the hypotenuse, which is actually Y over R. So Y is 5 over the square root of 41. Anyone see any problems? The denominator is not rationalized, so we have to rationalize the denominator. So we multiply it by the square root of 41. So your answer is 5 square roots of 41 over 41. And that is your value for the sine of theta. All right, let's take a look at the cosine of theta. Cosine of theta is equal to opposite over the hypotenuse, which is also X over R. Our X value is, let's see, our X value is 4 over the hypotenuse, which is the square root of 41. Now, you can, if you get tired of, you don't have to write that each time. You can just say 4 square roots of 41 over 41. That's okay. If you still want to write the multiplying the denominator and the numerator by the square root of 41, just like we did there, that's okay. But it's all right to skip that step as long as you're getting the right answer. Okay. And our last angle will be tan theta. Tan theta is equal to opposite over adjacent, which is y over x. So our y value is 5 and our x value is 4. And we don't even have to rationalize the denominator on that, so that's good. Okay, now I'm not sure if you've seen cosecant yet, so let's just go over that real quick. It's cosecant, and it's of theta, is equal to CSC theta. That's how it's abbreviated. And the cosecant is equal to 1 over the sine of theta, okay? So basically it's the inverse of the sine of theta. So if we look up here, the sine of theta is y over r. So the cosecant is r over y, all right? So let's take a look at the secant of theta, and that's abbreviated SEC. Secant of theta is 1 over the cosine of theta, okay? So it's the reciprocal of the cosine of theta, so it's going to be r over x, okay? And our last one is the cotangent of theta, and that is COT theta. Cotangent of theta is equal to, I'm running out of space here, 1 over the tan theta, which is equal to the inverse of that, so it would be x over y. Okay, so now let's take a look at this with respect to our problem here, okay? If we know that we are looking for the cosecant, why can't I write cosecant? Cosecant of theta is equal to the inverse. Now, the thing is, what we should do is we should look at it right here before we rationalize it, because what you're going to notice is it's going to be the square root of 41 over 5. And we don't need to do any rationalizing with that because we're allowed to have the square root in the numerator. So the secant of theta is equal to, we look up here, the square root of 41 over 4. Okay, and the cotangent of theta is equal to 4 over 5. Okay, now there's a couple of homework problems on this. It shouldn't be too bad. I think that mostly should be review. All right, now you're going to have to let me know how the pen is working. I was a little tired of the permanent marker because it kept bleeding through to the next page. So let's see how this goes. If this is clear enough, let me know. We'll keep going with just using pen. All right, so we need to talk about some trig identities. All right, the first trig identity is the fact that tan theta is equal to sine theta over cosine theta. All right, and also that the cotangent of theta, remember it's the reciprocal, is just equal to the cosine of theta over the sine of theta, okay? The next one that we need to know, the next trig identity is sine squared theta plus cosine squared theta is equal to 1, okay? Now this might be confusing, but all this really means is you take the sine of theta and square it, plus the cosine of theta and square it, and that's equal to 1. All right, the proof for this actually comes from the Pythagorean theorem, and if you have any interest, it's in the book. But we'll skip the proof for right now. We'll just accept that sine squared theta plus cosine squared theta is equal to 1. All right, let's keep moving on here so we get some examples. Now, I have some of this written out because I have these charts, and the charts are going to take a lot of time. So hopefully we'll see how this goes. Now, I am on page 559. Okay, and these are the problems 9 through 15, and they want us to fill out the chart. All right, so I've done 2 examples for you to show you how they work. If we take a look at number 9, the sine of theta is equal to 3 over 5. And they're telling us they want to know what the cosine of theta is and what the tan of theta is. So what we do is we use that trig identity that I just explained to you, that the fact that the sine squared theta plus the cosine squared theta is equal to 1. Okay? So what we do is we know that the sine of theta is 3 over 5. So if I take 3 over 5 and square it, plus the cosine squared theta is equal to 1. 3 squared is 9. 5 squared is 25, so that's going to be 9 over 25. I actually skipped a step and I subtracted 9 over 25 from both sides. So you have cosine squared theta is equal to 1 minus 9 over 25. We're almost there, okay? So we take the square root of both sides. Well, actually, you have to change 1. If you just have the fraction key on your calculator, you can put in 1 minus 9 over 25. But if you don't have your calculator, just change 1 into 25 over 25. So then that would be 25 over 25 minus 9 over 25, which gives you 16 over 25. Okay? But that's cosine squared. So then what we have to do is we have to take the square root of both sides. So the cosine of theta is equal to 4 over 5. Okay, so then you'd go over here and you'd put that in your chart. Cosine theta is equal to 4 over 5. Okay, you're not quite done. We have to figure out the tangent. All right, so we go back to our trig identities and remember that the tan of theta is equal to the sine of theta over the cosine of theta. So we know that the sine of theta is 3 over 5 over the cosine of theta, which we just find, which is 4 over 5. Now, blast from the past for all my algebra kids, we have to keep, change, and flip. What that means is you keep your fraction, your first fraction, exactly the same. That's 3 over 5. Then we change it from division to multiplication. That's where the change comes in. And you flip your second fraction, the fraction that was in the denominator. So 4 over 5 flips to 5 over 4. So anytime you have a fraction divided by a fraction, what you want to do is you keep the first fraction, you change it to multiplication, and then you flip the fraction that was in the denominator. So 3/5 divided by 4/5 is equal to 3/5 times 5 over 4. And now if you have that fraction key on your calculator, you can say 3/5 divided by 4/5 and you'll get the right answer. All right, but let's take a look at this. So we have the 5's cancel out and you're left with 3 over 4. Okay, now remember that was equal to the tan theta. Okay, because tan theta is equal to sine over cosine. So tan theta is equal to 3 over 4, and we can put that in the chart. Okay, now I am going to go over a second one, and I'm going to assign 2 for homework, because I found that after going over the first one, I'm like, okay, I think I got it, but then I wanted to do another one. I think if once you do 2, you'll get it. Okay, so let's take a look at number 12. In number 12, they tell us that the sine of theta is equal to the square root of 2 over 3. So that's what we have here. I just wrote it down here next to number 12. The sine of theta is equal to the square root of 2 over 3. So we use that same trig identity that we used before. Sine squared theta plus cos squared theta is equal to 1. So we're going to take the square root of 2 over 3 and put it in for the sine of theta and square that, plus the cosine squared theta is equal to 1. Okay, so we're going to subtract this quantity from both sides. So cosine squared theta is equal to 1 minus, where did I get that 2 over 9 from? It's from up here, because the square root of 2 squared is 2, and 3 squared is 9, okay? So we have cosine squared theta. Now I changed the 1 into 9 over 9 so I could get a common denominator. Cos squared theta is equal to 9 over 9 minus 2 over 9. Okay, 9 minus 2 is 7, so we have 7 over 9. The problem is, it's the square root of 7 over 9, which actually is the square root of 7 over the square root of 9. Okay, we're not going to have any problem rationalizing the denominator because the square root of 9 is 3. So your answer for cosine theta is equal to the square root of 7 over 3. You're almost done. Just see the process is exactly the same for every one of these, okay? If you look at the chart, they either give you the sine or the cosine. So that's why we're using this method here. Okay, so you know what the sine is and you know what the cosine is. So now we can use that information to find out what the tan is. So remember, if you look up here, tan theta is equal to sine theta over cosine theta. Tan theta is equal to sine theta, which is the square root of 2 over 3. So that's in our numerator. And then cosine theta was the square root of 7 over 3. Okay, so we're going to do our keep, change, flip. We keep the first fraction, square root of 3 over 2. We change it from division to multiplication, and we flip the fraction that was in the denominator. So we have 3 over the square root of 7. Okay, the 3's cancel out. You have the square root of 2 over the square root of 7. We need to rationalize that denominator, so you're going to multiply the denominator and the numerator by the square root of 7, which will give you an answer of the square root of 14 over 7. All right, that looks pretty good for those two examples. Now, let's take a look at the next one. We're getting there, I promise. All right, some of this I wrote out in advance. I usually rewrite it because I kind of ran out of time today. We'll go with what I already have written today. Okay, and all of this is in the book if there's something that you're confused about. Now, what they're going to do is they're going to give us a triangle, and notice how the angles are uppercase. This is angle A, this is angle B, and this is angle C. The corresponding side is lowercase. So the angle that's across from angle A is lowercase a. The angle that's across from the side that's across from angle B is a lowercase b, and the side that's across from C is a lowercase c. It's hard to tell between the upper and lowercase c's, but that's all right, we can figure it out. Okay, so the next thing that we need to talk about are cofunctions. So if we take a look at this, this is a right triangle, so we have the sine of A, okay? The sine of A is opposite over the hypotenuse. So the sine of A is going to be lowercase a over c. All right? But now, what I want you to see and what makes this a cofunction is if you look at what is the cosine of B. So if we're looking at the cosine of B, it would be adjacent over hypotenuse. So that would be A over C. So a cofunction means that the sine of A is equal to the cosine of B. Okay? So tan and cotangent are cofunctions as well. And if you're not sure, work it out. Tan of A is equal to the opposite over the adjacent. So that would be A over B. But then the cotangent of B, you would have to figure out what the cotangent of B is. So it's the adjacent over, because remember the cotangent is the inverse, so it would be the adjacent over the opposite, which would be A over B. So they actually, every single one of them works out. You can work that out if you don't trust me. Now, what you have to be careful with these cofunctions are, this is if and only if A plus B is equal to 90. That's kind of fancy language, but basically what that means is it must be a what? A right triangle. Yep, because think about it, the sum of the angles in a triangle are equal to 180 degrees. So if this is 90, then A plus B will equal to 90. Okay, so these cofunctions only work in right triangles. All right, now I haven't found a use quite as of yet for the cofunctions. I went to look at the examples on page 559, and if you look at number 17, it says the cosine of, now I'm not sure what this Greek letter is. We'll call it phi for now, but I don't think that's it, but that's all right. It's actually drawn differently than a theta. So the cosine of phi is equal to the sine of 40. Okay, so what we know is if this works, if this is they're telling us this, that the cosine of phi is equal to sine of 40. Well, when we know that these are cofunctions, that we know that A plus B must equal 90. So if this is 40, you know that B must be 50 because they have to add up to be 90 degrees. We probably may have to come and do other problems with cofunctions, but for right now, it seems like that's all that they have to do in the book with the cofunctions, all right? And that, luckily, that's not too bad. That's a pretty easy one. Okay, Now, the last thing that we want to go over today, before I give you your homework, is this. Okay. Now, in the book, there's actually a blue chart, and it tells you that it might just be easier to make the chart, and I actually think it is. Okay, so what I would do is I would take some time. I would draw a 30, 60, 90 degree triangle. Now, it can just be a sketch. Okay, it doesn't have to be perfect, but the the legs are 1 and the square root of 3, and the hypotenuse is 2. Okay, so that's just the information that we're given. All right, now in the book, they've got our 45 degree triangle drawn like this. Let's see, like that. All right. But the thing is, what you have to remember is, and I think sometimes we get so used to either it being in this corner or this corner, we forget that we could actually rotate that entire triangle so that the 90-degree angle is at the top and the hypotenuse is over here at the bottom. Okay, and I drew it this way on purpose because I want to get you out of thinking that the 90-degree angle has to be either here or here. Okay, but let's take a look at this. So if we are going to put this into a form that we're used to, the hypotenuse is the side opposite the 90-degree angle. So this would be the square root of 2 over here. Okay, and then each of the legs is equal to 1. All right. Now, this chart really isn't very hard to fill out because, and I want you to look at it, I would definitely write this chart in your notes and fill it out. Don't just copy it out of your book. I want you to actually think about where all of these things came from, okay? If we take a look, if our angle is 30 degrees and we're looking up here at this 30, 60, 90 degree triangle, the sine of 30 degrees is the opposite over the hypotenuse. So that would be 1 over 2. So let's take a look at the cosine. The cosine of 30 degrees is the adjacent over the hypotenuse, okay? So this would be the adjacent, which is the square root of 3, over the hypotenuse, which is 2. That's where that comes from, okay? Now the tangent of 30 degrees, you may be saying, whoa, 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 where did this come from? Let's take a look. The tangent of 30 degrees is equal to the opposite over the adjacent. So I have it written down over here. The tangent of 30 degrees is 1 over the square root of 3. This is important to remember because we're going to have to deal with cotangent later. So I put it up here on top. The tangent of 30 degrees is equal to 1 over the square root of 3. The problem is we have to rationalize the denominator. So we're going to multiply the numerator and the denominator by the square root of 3. So your answer is going to be square root of 3 over 3, which is what gets put in the chart here. Okay? So let's take a look at the cosecant. Now remember, the cosecant is the inverse of the sine. So if the sine is 1 over 2 and we flip that, it just becomes 2 over 1 or 2. Okay? Now let's take a look at the secant. When we flip that, the secant is 2 over the square root of 3, which I wrote over here. If you do need to do any rationalizing of the denominator, I'd write it off to the side and make sure you rationalize it, okay? So you multiply the numerator and denominator by the square root of 3, so your answer is 2 square roots of 3 over 3, okay? So that would be the secant of 30 degrees, 2 square roots of 3 over 3, okay? Now the cotangent, remember I said we have to remember what the tangent was before we rationalized it. Okay, before we rationalized it was 1 over the square root of 3. So if I take the inverse of that, that is just the square root of 3. Okay, now what I want you to do, now the cool thing is I actually think the 45 degree angle is, because remember these legs are exactly the same, so you're going to have a lot of stuff that's matching. So what I'm going to recommend that you do in your notes is I want you to use the triangles that we have up here and fill them in for the 45 degree angle and the 60 degree angle. And if you look over here, you're going to see there's one that has to be rationalized. Okay? But what I want you to do is I want you to figure them out on your own so you get good at figuring out, you know, sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse. Tangent is opposite over adjacent. You have to, I want you to get used to filling all of these in. Okay? Then, once we have all this filled in, now here's the thing. Some people will tell you, well, you just have to memorize this. I'm not a big fan of memorizing things because sometimes I forget things. So I think what's actually better than memorizing it is knowing where all of the values in the table come from. So you could make a quick sketch of this, and then you could find the value that you need. Okay? If you want to memorize it, that's fine. But if I were you, I would just know where all of this came from. Like if you look at the 60-degree angle, just look at the 60-degree angle here. It would be opposite, which is the square root of 3, over the hypotenuse, which is 2. Okay? So a quick sketch will get you every single thing that's in this table. All right? And now, but what are we going to use this table for? Well, for your homework. I'm not exactly sure where to go from here, but that's what it looks like. Okay? I haven't gone ahead in the book yet. It was all I could do to get this ready to give you today. So hopefully, it will make more sense later. Okay. Now what I'm going to do, actually, I want to take this table out so that we can use it for the homework problem that we're going to go over. All right. So we'll put that there. Let's put our table over here, and we'll take a look at the homework problem now. Okay, so this is our table, which we're going to need now for our homework. See, we just filled out this table so we can go ahead and use this table. But if you needed it on a test or something, I would do a sketch and figure out what it was. There's the 1, 2, square root of 3, and the 1, 1, square root of 2. Okay? For some reason, I did number 22 first. I think I'm going to wait on that, and we're going to do number 20 first, and then we'll go back and we'll talk about number 22. Okay? All right, so let's take a look at number 20 in the book. All right, they tell us for number 20 in the book that A, lowercase a, that's the side, is equal to 6, and then angle A is equal to 30 degrees. I like to make a little sketch, so I did that over here, okay? The angle opposite A is lowercase a, so this is 30, and so the angle opposite this side, so this is the 30-degree angle, and this is the side length, which is 6. We know this is B, and this is C. It's all set up just like this, like it says in the picture there. Okay, so how do we use this table? Now, let's take a look. We know that the sine of 30 is equal to the opposite over the hypotenuse. Okay, so the sine of 30 is equal to 6 over C. All right, but now what we can do is, what is the sine of 30 degrees? We have to go back on our table and see the sine of 30 degrees is 1 over 2, or 1/2. So what I can do is I can say I'm going to replace the sine of 30 degrees with 1 over 2 is equal to 6 over C. And that's how this works. That's how these problems are asked. Okay? So now what we need to do is we can cross multiply, and we say C is equal to 6 times 2, which is equal to 12. Okay, and the book wants to get all of our values. So C is equal to 12. Okay, now they only tell us that that's a 30-degree angle, but if this is a 30-degree angle, we know for sure that that's a 60-degree angle, because it has to be. It's a 30, 60, 90-degree triangle. Okay, the problem is, so you've got lots of different options now here to find out what B is, but what I'm going to do is I'm going to go over exactly the same way that I did in the first part of the problem. Okay, so I know that the reason I picked the tangent of 30 degrees is because the tangent of 30 degrees is the opposite over the adjacent. Okay, and I want to know what B is. We don't know what B is as of yet. We only know A and C. Okay, what you're saying is, well, why can't I use the Pythagorean theorem to find B? You absolutely can, but I want to give you some practice using the table. Okay, so let's take a look. So the tangent of 30 is equal to 6 over B. Okay, so we look in our chart. What is the tangent of 30 degrees? The tangent of 30 degrees is the square root of 3 over 3. Okay, so the tangent of 30 degrees is equal to the square root of 3 over 3. Now we know that that is equal to 6 over B. All right. So now we can just cross multiply. So what I have here is I have B times the square root of 3, that's where that came from. The b times the square root of 3 is equal to 6 times 3, which is 18. Let me write this over here. B times the square root of 3 is equal to 18, okay? So then what I did was I had to solve for b, so I divide both sides by the square root of 3, okay? So b is equal to 18 over the square root of 3. The problem is that we can't have the square root of 3 in the denominator, so we have to rationalize it. So the square root of 3 times the square root of 3 is 3, and we have 18 square roots of 3 over 3, okay? So now, let's see here. So 18 divided by 3 is 6, so your answer is 6 square roots of 3. And we found out all of our information because b is equal to 6 square roots of 3. Okay, we know all of our angles. We know it's a 30, 60, 90 degree triangle. We know side A is equal to 6, B is 6 square roots of 3, and C is equal to 12. And we found all of this information by using this chart over here. Okay, let's take a look at 22. Now 22 is actually easier because it's a 45 degree angle. So let's take a look. If we know that angle A is equal to, what in the world? I don't know why that says that. I think that's supposed to be a B. Okay. They give us the information that angle A is equal to 45 degrees. We know that this is a right angle, so immediately we already know that angle B is equal to 45 degrees. Okay, because this is 90, this is 45, this must be 45 because they have to sum up to be 180 degrees. Okay, we found all of the angles, but now we need to find the sides. Okay, they gave us in number 22 that angle A was 45, so I have my little triangle over here, and they gave us that the hypotenuse is equal to 10. Okay, so I just decided to find what the side A was equal to first. Okay, so if I want to include A, I have to think about it. Which trigonometric function uses that? Well, if I do the sine is opposite over the hypotenuse. Okay, so we have the sine of A is equal to the opposite, which is A, over the hypotenuse, which was given, that was equal to 10. Okay, now we know that A is 45 degrees. So we're doing the sine of A, so we have to look at our chart. The sine of 45 degrees is the square root of 2 over 2. Okay, so instead of the sine of A, we're going to replace that with the square root of 2 over 2 is equal to A over 10. We're going to cross multiply that. 2A is equal to 10 times the square root of 2. Divide both sides by 2. And you get A is equal to 5 square roots of 2. Okay? Now here's the thing. You know that this is a 45, 45, 90 degree triangle. Okay? You already know that B is equal to 5 square roots of 2. Okay? Because if these angles are equal, their corresponding sides will be equal. Okay? If you want to look at it later, you could say, oh, well, how could I find it using the charts? Well, just use cosine. The cosine of A is equal to B over 10. The cosine of A is the square root of 2 over 2. And you solve that, and you get that B is equal to the square root of 2. Okay? Now, this is the last example, and I'll give you your homework. And remember, it's not due until tomorrow at 3, because I got a little bit behind today. Okay. So let's take a look at number 24. 24, they give us that A is equal to 3 and C is equal to 6. Okay, so the side opposite angle A is that, which would be 3, and the side opposite the hypotenuse, which would be C, that would be 6. Okay, so we filled in our diagram. Now, in order to use our chart, I think we need to figure out what this leg is. So we can do is we can say A squared plus B squared is equal to C squared. So that would be 3 squared plus B squared is equal to 6 squared. All I did is I took that information here, okay? So then I subtracted 3 squared from both sides. So I get B squared is equal to 36 minus 9, okay? 36 minus 9 is 27. So B is equal to the square root of 27. Now the square root of 27 is 9 times 3. Okay, the square root of 9 times the square root of 3. Well, the square root of 9 is 3, so your answer is 3 square roots of 3. Okay? Now, we now know that the sine of A, so what we found that B is equal to, let's see what we got here. B is equal to 3 square roots of 3. Okay? All right. Now, here's the thing. So let's see what we got here. The sine of A is going to equal to the opposite, which they gave us, which is 3, over the hypotenuse, which is equal to 6. Okay? So the sine of A is equal to 3 over 6. But if we look at our chart, the sine of A, isn't that interesting? Okay, I lost my train of thought. Sorry about that. They told us that the sine of A is equal to 3 over 6. Well, 3 over 6, see what we're doing now is they want to know what the angle is, okay? So take a look at this. Our sine of A was 3 over 6. Well, 3 over 6 can be reduced to 1/2. Well, what does the angle have to be if the sine of A is equal to 1/2? Look over here. So where is the sine equal to 1/2? The only place that the sine is equal to 1/2 is right here, okay? So if we know the sine is 1/2 just from on the sides that we were given, we can go backwards now. If the sine is 1/2, we know that A had to be a 30-degree angle, okay? You could do the same thing, and if you want to for practice, you can do the same thing with B, okay? And you can figure out what it is. But the fact of the matter is we already know that it's a 90-degree triangle, and we just found out that A was equal to 30. So if A is equal to 30 in a 90-degree triangle, B is going to have to be equal to 60. Okay? All right. Now, what you're probably need some practice on this. So let me give you some homework here. Let's just write the homework on the back of here. All right, I picked out some problems that matched kind of with what we did here. So we're on page 559, all right? And let's try number 5, 11, 13, 19, 21, 23, and 25, okay? I know that this was a lot. Let me know if you have any questions. If it's taking you longer than expected, don't take more than 30 minutes doing that. If you have any, just make sure that you send me a pic of what you do have done by 3 o'clock. I'm hoping tomorrow will be a lighter day so that if you had time, then you can finish that if you didn't finish it today, okay? All right, so that's it. That's our lesson on trig functions. If you have any questions, ask me on Jupiter Ed, and otherwise, I will see you tomorrow. Take care, and God bless.